Welcome to another unit on the hypergeometric distribution. Let's have a closer look at our exercise. Here we have university offers 3 study programs: national management, regional brand management, and physiology and management. The shares of the 3 programs are 45%, 25%, and 30% respectively. In the course of a market research course with 20 students, interviews are conducted. Sample of 3 randomly selected students is considered. Our tasks now: first, what is the probability that none of the students in the sample study PM? Then, what is the probability that at least 2 students study PM? And finally, given a study group in a course with 3 students, you know that 1 student is already studying NM. What is the probability that at least 1 of the other 2 students is studying RBM? Well, let's get right into it and start with part A. Part A, which is still, I would say, relatively straightforward, because what we are going to look here for is the probability that 0 of the students in the sample study PM. So we're looking for the probability that our random variable is 0. Well, before we can actually go into more detail and discuss what information we have given, we first need to decide which distribution to actually consider. Because we are selecting students here, we're making groups out of the students, we can select each student only once, because once he is part of a subgroup, we cannot select him again. So if we say we have a group with 3 students, it cannot be 3 times the same student. So since each student can be selected only once, this means we have to work with the hypergeometric distribution. For the hypergeometric distribution, I need to have the overall number of board observations, cases I can select from, the large N. Well, we have this here. That's our 20 students. Then I need to know the number of observations with a certain property. So here the property is the student studies PM. So I need to know the absolute number. That's the first problem, because in my text, I only know that 30% study PM. But well, 30% of 20 students, that makes 6 students. That's actually the first 2 parts here. 6 students study PM out of a total of 20 students. Then finally, well, we need the size of the sample, but that's relatively straightforward. That's the 3 students we're going to select. And we need to know how many of the students in the sample should have the important property. Well, that's here the 0. So that's the small n, and that would be the small k. If we have all these informations, we can simply put this into the probability function for the hypergeometric distribution, which is just large K over small k. So 6 over 0 times, then up here I have large N minus large K. So the number of students who do not study PM over 3. That's small n minus small k. That's more or less how many of the students in the sample should not study. Should not study PM. So all of them should not study PM, because 0 should study PM. All of this is divided by 20 over 3. 20 is the number of total observations, number of total students, over the size of the sample, so large N over small n. Well, that's already 1. So if we put this into a calculator, for this part we get 364, for this part 1140. We divide those two by each other, we get as an end result 31.93%. Or in other words, the chance that in a group of 3 there is no one who studies PM is roughly 32%. Well, that already concludes the first part. So let's continue with the second part. Here we're going to look for the probability that at least 2 students, so 2 or more students, study PM in this sample. So it's larger or equal to 2. Well, we could here calculate the probability that it's 2 plus the probability that it's 3. We have to calculate 2 new probabilities in this case. Or we could work with the counter probability. So with 1 minus x being smaller than 2, really smaller. So this means smaller than 2, that's only the 0 and the 1. So this would look like this here. Well, again, I would have to come up with 2 probabilities, but if I think back, this probability we already calculated in part A. So actually we only have to calculate only 1 probability in this case. Well, so that's half the work, so we're going with this approach. The information we have is still the same as in the first part. So it's a large K of 6, a large N of 20, a small n of 3. Then if we calculate this, well, we're using this, we're going to take for this probability the value we have from A. And for this one, we calculate 6 over 1, so large K over small k. That's this one. Large N minus large K. That's the 20 minus the 6. Small n minus small k, so 3 minus 1 gives us the 2. And finally divided by large N over small n, 20 over 3. Well, if we also put this into the calculator, that's 6, that's 91, and that's again 1140. So in the end, if we calculate all of this, we have the first part from A, those 2. That's then the second part, taken together results into an, well, answer of 20.18%. So the chance that in our small group of 3 people, there's at least 2 people who study PM is roughly 20%. Well, that was already the second of our 3rd parts, but those 2 were relatively straightforward. For the next one, we actually have to think a little bit. So if I start with part C, what I actually know here is in the beginning, I have 9 students who study NM, 5 students who study RBM, and 6 PM students. Then I have my sample of 3 students, and I already have the information that one of those 3 students studies NM. So since one of them already studies NM, for the remaining 2, I can only select from those students. One of them is already gone, and also one of the places in a group is already gone. Well, this changes the probability for all of those ones, because, well, I might have only one NM student less, but the large N, which is the sum of all students, decreased from 20 to 19. So I'm working with a large N of 19. I'm concerned about the RBM students, so here large K is 5. My sample size is only 2 because I only have 2 remaining, well, positions in my group left. And I want to know what's the probability that I have at least 1 RBM student, so that the probability of X being larger or equal to 1. 1 or more students should study RBM. Well, we can formulate this as probability of X equal to 1 plus probability of X equal to 2, or we can again work with the counter probability. That's what I'm going to do here, because the counter probability is 1 minus x being smaller than 1. Well, there's only one value smaller than 1, and that's 0. So in this case, with the counter probability, again, I only have to calculate one probability. So I have 1 minus, and then that's the large k, that's the 5 here, over small k, that's the 0, times large N minus large k. We have to recall large N was only 19. So 19 minus 5 is the 14. This is small n minus small k. So only 2 places remaining. So small n is 2. Small k was 0. So 2 minus 0. And we divide by large N over small n. So 19 over 2. Which in the end will result in a value of, well, 46.78%. So the chance that of the remaining 2 students in the group, at least one of them will study RBM is, well, slightly below 47%. Well, that's already everything there is to this exercise. I hope you enjoyed it. I say goodbye and see you next time.